Today we're going to look at solving radical equations as well as solving absolute value equations. Let's start with radical equations first. Here's your steps. First, we're going to isolate the square root. We're going to get it all by itself. We're going to get rid of the radical depending on what type it is. If we have a square root, we'll square both sides. If we have a cube root, we're going to cube both sides. Then we'll solve the equation like normal, and then we have to look to see if we need to check our solution. We check if we have an even indexed radical. So if you think back to Algebra 2, when you were taking the square root of a negative number, you learned the square root of like negative 25 is 5i. 5i is an imaginary solution. When we're solving these equations, we're going to want real solutions. So anytime we have an even indexed radical, we're going to write no real solution. Now, if you think back to Algebra 2 again, and you were taking like the cube root of negative 8. The cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. You could take the cube root of a negative number. You just could not take the square root, or the fourth root, or the sixth root of a negative number. So we only have to check whenever we have an even indexed radical. Let's look at our first example. This very first one here, our radical is not by itself. We got to get rid of plus 5 first. To get rid of plus 5, we're going to subtract 5 on both sides. A radical is now by itself. We got to check what kind of radical we have. We have a square root. Square root means it has an index of 2. Since it has an index of 2, we need to get rid of it. So we're going to square both sides of that equation. Square and square root cancel each other out. And so on this left side, all we're going to be left with is x minus 7. 13 squared is 13 times 13, 169. Let's solve for x. Add 7 to both sides. We get x equals 176. Before we can say we're finished, we go back and see if we need to check our solution. We go basically look at the radical and see what kind of index we have. If it's even, we check. If it's odd, we don't. Remember, this index is a 2. 2 is an even number, therefore we have to check. We check by taking the x value of 176, plug it into the radical part. All we have to check is making sure that this is a positive number. Because we can take the square root of a positive number, we're not allowed to take the square root of a negative number. Therefore, this one's positive, and 176 would then be a good solution. So we're all finished on this one. Let's look at the next example. This time we have a cube root. We got to get our cube root all by itself. Let's get rid of our plus 3 by subtracting 3 on both sides. This time we have a cube root. To get rid of cube roots, we're going to cube both sides. Cube root and cube's going to cancel out, so you got your 2x plus 5 equals. Be careful over here, that's negative 2 times negative 2 times negative 2, which equals negative 8. Solve for x like normal, subtract 5 on both sides, divide both sides by 2, and it looks like our answer equals negative 13 halves. However, we didn't look to see if we need to check. We go back up to the top, look at your index. Your index is a 3. 3 is an odd number. We do not have to check the odd ones because we can take cube roots of negative numbers just fine. So this is all finished. Moving on to the next one. Notice you have a square root on both sides of that equal sign. Our first step hasn't changed. We're still going to look to see if we have a radical by itself. We actually have 2, one on each side of the equation. Doesn't matter which one you focus on. Now, because these are square roots, we want to get rid of a square root by squaring both sides. When you simplify, you get 2x minus 5 equals x plus 6. Solve for x like normal. Let's subtract x on both sides and add 5 to both sides. We get x equals 11. So we need to see if we need to check. We're going to go back up. We've got an even index radical on both of these. They're both square roots, which means we've got to plug the 11 into both radicals and make sure the parts underneath stay positive. If one of them doesn't, it's automatically no solution. So 2 times 11 minus 5, that's a positive number, and 11 plus 6 is also positive. Because they are both positive, x equals 11 is a good solution. All right, So on this next one, notice your radicals are not isolated. They're not by themselves. So we're going to first check, get one of them by itself. And I always like to look and keep the more complicated one by itself. So this one looks more complicated to me. I need to move the square root of x to the other side. It's currently a positive square root of x, so to move it, subtract it to the other side. Because this radical is by itself, we're ready to square both sides, and we know the square root of x minus 20 squared is just x minus 20. Square and square root cancel each other out. Be careful over here on the right side. Because there's two terms separated by a minus sign in this example, it's a binomial. Binomial squared means you have to write that binomial twice and FOIL it out. 10 times 10 gives us the 100. 10 times the negative square root of x is negative 10 square root of x. 10 doesn't have a radical. You cannot take it inside that radical. You multiply the 10 times the negative 1 and leave the square root of x behind it. The inside terms did the same thing, negative 10 square root of x. Last times last, negative times negative is positive. Square root of x times square root of x is square root of x squared. Square root and square cancel each other out. We're left with x. Okay, now, you're going to notice we got like terms here in the center. Let's combine them. And we got negative 20 square root of x. Now, we still have this square root, and we're trying to solve for x, and x is stuck underneath it. Which means we've got to start our process over again. We've got to get our radical all by itself. So we're going to move this 100 over by subtracting it. We're going to move the x over by subtracting it. We end up with negative 120 equals negative 20 square root of x. At this point, our radical's still not by itself. We actually have a negative 20 times that square root of x. To get rid of multiplication, we divide by negative 20. So we end up with 6 equals square root of x. Got to get rid of the square root. Square both sides. We get x equals 36. All right, do we need to check? Oh, we got even indexes. They're both 2's. So we're going to plug in square root of 36. And we're going to plug in square root of 36 minus 20. 36 is positive. 36 minus 20 is also positive. Therefore, we don't need to check our answer. X equals 36 is a good result. Excuse me. Let's look at this next one. We're going to pretend like we solved this equation. We didn't, but let's pretend that we get x equals negative 4. We're going to plug the negative 4 in the x spots. You've got two radicals. You've got to plug them in both. When you plug the negative 4 in, negative 4 minus 3 is automatically a negative number. We can't take the square root of a negative number, which means we're going to write no solution for our answer. You cannot write undefined. You're not dividing by 0. All right. We can also take radicals and write them as fractional exponents. Fractional exponents are just radicals written in a different form. So let's pretend that we have the square root of x. We know x has a power of 1 on it. We also know the square root has an index of 2. So anytime we have the square root of x, we can also write the square root of x as x to the 1/2 power. So anytime you see a fractional exponent, it's just telling you you have a radical. The root on the bottom is your index on your radical. So if we have the cube root of x, it's the same thing as x to the 1/3 power. We can put anything inside. The 4th root of smiley face is the same thing as smiley face to the 1/4 power. All right, so if you look at this next one, we have the 5th root of x squared. So write your x and then raise it to the 2/5 power. Remember, roots on trees go down. So roots with fractional exponents are on the bottom. The index goes on the bottom. Okay, so let's look at this next example. We've got 2x raised to the 3/4 power equals negative 8. We have a fractional exponent, which means we have a radical. We know how to solve radicals. We've just been doing it. You could rewrite this as a radical. You could write it as the 4th root of 2x to the 3rd power. However, if you write it that way, you're going to have to get rid of the 4th root, and you'll also have to get rid of the 3rd power. So it's quicker to solve these by taking both sides of that equation and raising it to the reciprocal of that power. The reciprocal means you flip this fraction over. So we're going to take both sides of this equation and raise it to the 4/3 power. You'll see that it's quicker because notice these powers are canceling out, and you're going to end up with just 2x equals, here you could take the cube root of 8, which is -2, and take -2 to the 4th power. -2 times itself 4 times gives you 16. You can also use your calculator if you want and type it in, -8 raised to the 4/3 power. Notice I had to put the -8 in parentheses. To get it up in the exponent, you use the caret, and then you can just hit 4 divided by 3, and it gives you 16. So if you're comfortable with your calculator, you may use it. Okay, solve for x, divide both sides by 2, we get x equals 8. Do we need to check our answer? Well, we gotta see, do we have an even indexed radical? Remember, the root is on the bottom. So because that root is even, we have to check it. So to check it, we're going to put 8 in the x spot, and 8 times 2 is positive, so this is a good answer. Looking at the second example here, we're going to raise both sides to the 3/2 power because we've taken the reciprocal. So notice these powers are going to cancel, and you're going to get x minus 5 equals. We have to be super careful. Anytime we took the square root of both sides of an equation, we also had to remember the plus or minus. We took the square root because this is right here is a 2 in this root spot. So we took the square root of both sides, which means when we simplify this side, we'll have to put a plus or minus in front. So the square root of 16 is 8, and 8 cubed is 64. Again, you could type that in your calculator if you prefer. This creates two problems. We've got the x minus 5 equals positive 64. We've got the x minus 5 equals negative 64. We're going to add 5 to both sides on both equations and get two solutions. Do we need to check our answer? Go back to the original. Notice your root is a 3. 3 is odd. Odd means we don't need to check. Both of these are good solutions.